The Office of Geospatial and Technology Management at the North Carolina Division of Emergency Management needed to develop a methodology for assessing the potential damage caused by flooding so they could help local governments make more timely and accurate decisions when preparing for and responding to natural disasters. The agency used a combination of airborne and terrestrial LiDAR to help determine the elevation of the first floor of every building in the state greater than 800 square feet. This information is very useful since flood damage is primarily determined by the depth of flooding within a structure. With the resulting data set, the Office of Geospatial and Technology Management was able to use ArcGIS to help estimate the impact of Hurricane Earl, which was predicted to pass along the North Carolina coast in September of 2010. To assess the potential damage from flooding as a result of the hurricane, the statewide building data set was overlaid with the prediction of storm surge from NOAA's slosh model, which is seen here. The slosh output estimates the storm surge within a given area based on the speed and intensity of a hurricane. In this case, Hurricane Earl was a Category 3 storm moving northwest at 15 miles an hour. As we zoom into Carteret County, we can see how the inland bay areas will experience higher levels of surge, which is typical of slower moving storms. Let's zoom in further and we can view the buildings that were measured by the Office of Geospatial and Technology Management. As we see here in yellow, these are all the building footprints for the county. Now that we have both the slosh output and the building footprint data, we can run a model to do some analysis with these two data sets. What we're running now is a spatial join, which will take the elevation of the buildings, the LiDAR derived elevation, and compare it to the elevation of the storm surge given from the slosh model. The difference between these two values will give us the water height at the first floor of each building. As we zoom into the Emerald Isle area, we can see each of the buildings symbolized by the water height at the first floor. So the buildings in yellow, orange, and red will have significant flooding to the structure, which could result in either a major loss or a total loss. We can also view a graph to view the total damage countywide. In this case, we can see there are over 5,000 buildings in the county that will have flooding on the first floor as a result of the storm surge from Hurricane Earl. So what this analysis allows us allows state and local governments to do is to be better equipped to help educate the general public about the risks they face, so they can make better informed decisions about how to better protect themselves and their property.